Good morning, my young friends. Today is Tuesday, May the 19th, and today we are going to continue our discussion of geometric optics, all right? In other words, the formation of images using lenses and mirrors. Now, there's a bunch of different aspects to this, so I'm going to start today just by going through what kinds of images can be formed by using a curved mirror. Now, before we go any further, you do have to realize that curved mirrors can come in two different forms. The first is obviously a concave form, like so, where the ray of light comes into the mirror and is then reflected. A convex mirror would be flipped around, and the light ray would hit this angle and bounce off. All right. And so that's what we're going to actually be looking at today. Now, today's presentation is going to involve an awful lot of drawing, and the rough sketches that you see. I'll try to give you, as soon as my new printer comes, I'm going to send you this, which is a printed version of what you'll need to know. It's coming, but for now, let's just play with the rough sketches that I can draw. So let's start by drawing a mirror, okay? And so I'm going to start out with a curved mirror like so. All right, and I'm going to draw the principal axis right to the vertex of this mirror. Now you got to pretend that that's a straight line. And so the vertex of the mirror is located here. I'm going to call the center of curvature of this thing a point C right here. And I'm going to place the focal point halfway between the vertex and the center of curvature. Now, let's see. I'm now then going to draw an object at a location that I'm going to call infinity. Okay, this is way beyond C. This is the length of a football field away from the spoon that you're looking at, or whatever it happens to be. Now, in this particular case, because the object is so far away from the mirror, any ray of light that I send through here is going to hit the mirror at essentially a parallel point, and then it's going to be reflected through the focal point. I missed the focal point there, but you get the idea. And so I'll send another one, and again, it's going to be running parallel to the principal axis. My desk is not perfectly smooth, apparently. And so that one goes off this way, and then one more strikes the mirror, is reflected through the principal axis, and goes off this way. Now, notice that all three of these light rays, because they were essentially traveling parallel to the principal axis, strike the mirror and are reflected through the focal point. So the image is going to be located where those rays of light come together. They all come together at one point. All right. So is there an image? Yes, indeed. The image is located at point F. The image is real because it's located on the same side of the mirror as the object is. And finally, the image is at a point. All right. And so there will be a focal point right there. Okay. All right. Now, so that's for an object at infinity. What if I do the same kind of thing, but rather than placing the object at infinity, I put it somewhere beyond C, but not at infinity? All right, so let's try that one. All right, so I'm going to draw myself. Here's my curved mirror. Here's my principal axis. Ooh, look at that. I'm getting better at this as we go on. And let's go back to the green. I'm going to place my center of curvature here, my focal point halfway between the center of curvature and the principal axis, and then I'm going to draw my object, let's say here. All right, so here's my object. And the object is going to be located beyond C, beyond the center of curvature, but not at infinity, not too far away. And so now I'm going to send my first ray of light running parallel to the principal axis so that I know exactly where it's going to be reflected through. It's going to be reflected right through the focal point. Now, for the next one, in this case, I'm going to send the ray of light, in this case, through the center of curvature, because if I do this, it's going to hit the mirror at a point where the ray actually is right on the normal line. So if the ray is going this way, the reflected ray will go this way. And so what happens? Well, notice that these two rays of light intersect right here. And so the image that I form is going to form between, I don't know what that happened there, is going to form between the focal point and the center of curvature. The image will be real. Come on. The image will be real because it's on the same side of the mirror. It will be smaller than the object, and it will be upside down, but it'll be between F and C. Okay. So that's case number 2. Case number 3 will involve putting the object directly at point C. So let's look at that at this point. So here's my mirror. Here's my principal axis. I'm going to place my center of curvature here. I'm going to place my focal point halfway between the center of curvature. And remember, this is the vertex of the mirror here. And now, if I draw my object right at this point C and send a ray of light parallel to the principal axis, it's going to strike the mirror and then be reflected through the focal point. Okay. Now, for the second one, I can't send it through the center of curvature like I did earlier. Let me send it through the focal point. And so now, in this case, if I hit the mirror here, it's going to be reflected directly so that it's parallel. I missed. What in the name of all that is holy? I missed, but I promise I'll send you real diagrams of this. But what you should have seen was that the image was right here, okay? And so in this case, the image is at point C, because that's where the two reflected rays should have come together. All right, if I had done this, I guess I didn't. All right, something like that. I guess I should have put my focal point a little closer. But in any event, the image is a real image because it's on the same side of the mirror. It's as the object is. It's located at point C. It's the same size as the object, and again, it is inverted. Okay, sorry for the mess on that one. All right, let's try the next location. Now, for our next trick, what we'll do is we're going to draw our mirror and again, our principal axis. So the vertex is here. I'll put the focal point here and the center of curvature twice the distance here. And this time, I'm going to draw my object between the center of curvature and the focal point. And so my object is going to be located here. Now, if I then draw two rays of light, the first one I'm going to draw parallel to the principal axis because I know that anything drawn parallel has to be reflected through the focal point. And the second one, in this case, I'm going to draw through the focal point because I know that it needs to be reflected parallel to the principal axis. In this case, and again, I haven't done a wonderful job with this, but now the object is located the object is located between C and F. The image is beyond point C, okay? It is a real image because it is located beyond or on the same side of the mirror that the object is. It is larger than the object, and it is again inverted, upside down. All right. So we're slowly moving our object closer and closer and closer to the mirror. This one is from between C and F. The next one I'm going to draw right at point F. Okay, so let's try that one. All right, we'll draw our mirror. We'll draw our principal axis. Here's our vertex. I'll put the center of curvature about here. Whoops, that's C. We'll put our focal point halfway between C and V. And this time, I'm going to draw my object right at the focal point. Now, first ray of light, again, I'm going to draw parallel to the principal axis. It's going to strike the mirror and be reflected through the focal point. The second ray, I can't draw through the focal point or the center of curvature this time, so now I'm going to aim right for the vertex. It's going to hit the vertex and it's going to be reflected, this way. And notice that now these two rays of light are parallel to one another. They're never going to come together. They're never going to come together. And so because the two rays are parallel to one another, when the object is at the focal point, no image will be formed. All right, no image will be formed in this case. Okay, now there's only one more place that I can put my object in front of a concave mirror, and that is going to be between the focal point and the vertex. Now this one's going to require a little bit of imagination. So let's move on here. Here's my mirror. Here's the principal axis. Here's the vertex. I'm going to draw my center of curvature here. The focal point is going to be located here. And this time, I am going to draw, my object between the focal point and the vertex. All right. Now, first ray of light, parallel to the principal axis, it's reflected now this way. The second ray of light, I'm going to draw such that it is located like so that it strikes the mirror and is reflected back through the center of curvature. Now, I didn't do a very good job here, but if I now notice these two don't meet, they're actually diverging on this side. Yeah, that says diverging, believe it or not. I'm going to move myself out of the way here. And now, if I continue these, and I'm going to cheat, these aren't going to be drawn perfectly straight, and I'm cheating. But I'm going to continue the principal axis here. And this time, the image is going to be located here. All right, so that it's actually inside the mirror. All right, so now when the object is between the focal point and the vertex, the image is going to actually be located inside the mirror. It's going to be a virtual image because it's not on the same side of the mirror as the object is. Notice that it is larger than the object itself, and rather than being upside down, it's right side up or erect in this case. All right, and so that's what happens when you get too close to a concave mirror. Now, to look at any of these images, go to the kitchen, grab yourself a spoon, and hold it in front of you, and kind of move it, and watch what happens to the image as you move the spoon closer and further away from your eyeballs. All right. Now, one more before we finish for today. And in this case, we're going to draw what's called a convex mirror. So now the curvature of the mirror, let's do that again. That was awful. Okay, so now the curvature of the mirror is going to be here, and I'm going to draw the principal axis right through. Pretend that's a perfectly straight line. And in in this case, notice that the center of curvature is located inside the mirror, and therefore so is the focal point. So if I place an object anywhere in front of this mirror, it does not matter where, okay? And I'll send a ray of light parallel to the principal axis. Once again, the ray of light is going to be reflected, but now here it's going to be reflected in essentially, nope, I missed. It's going to be reflected in this direction, such that it goes off something like that. But if I follow it backward, and I know this is a very tough diagram or thing to draw or look at. Same thing now. For the next one, I'm going to draw a ray of light such that it would pass right through the center of curvature. I missed that too, but all right. Now, and again, because I'm doing that, it's going to be reflected in the same along the same line. Now, notice, where do these two objects, or these two rays of light rather, intersect? All right. Well, they intersect right here. Okay. So, for a convex mirror, no matter where you place the object outside of the mirror, the image is going to be inside the mirror. So therefore, it's going to be a virtual image. Notice its size. It's smaller than the object. And again, it's a virtual image and it's erect, right side up. Okay. So that concludes my ugly little diagrams. Again, as soon as I get my new scanner here, I will throw this in. It's supposed to arrive tomorrow. So we'll see how all of that works out. But in any event, I will send you these diagrams. But those are the images, or the way that we form images with both concave and convex mirrors. All right, fellas, have yourself a lovely day, and I will see you sometime in the near future. Oh, don't forget, tomorrow is your review activity on waves. All right, I will post some information a little bit later on.